Assalamualaikum warahmatullah. Welcome to another beautiful class and basic class of physics in the chapter of refraction of light, and in this tutorial I'm going to explain about critical angle and the total internal reflection. So what is critical angle? Before going to explain it, do you really understand what is the refractive index? Do you really understand what are the laws of refractions and what are the basic of the refractive index and the process of refractions? In my previous videos I have uploaded 3 videos. This is the 4th tutorial that in my 3 videos I have explained some basics of these, and that will be applicable here also to understand the concept of critical angle. So see, this is water and this is air. So all three are same. Just imagine that light is falling in inclined positions from water to air. So what will be happening, as air is comparatively rarer medium than water? We know that water is denser medium. So when light incident from denser to rarer, then the refracted ray keep away from the normal. Okay, so the refractive angle is bigger than the angle of incident. So what is going on here? Think about it. Suppose a ray of light is falling here from water to air. So then it would be like this, but no, it would be refracted in this way. So suppose in this way, and think about it. This is actually N2 and this is N1. Think about, this is N2 and this is N1. So in case of air, N1, and in case of water, N2, we must know this N2 is the refractive index of water and refractive index of air. So what's going on here is actually theta 2 will form and here theta 1 will form. Now you think what's going on? I mean, this theta 1 is absolutely greater than theta 2. Okay, because light is incident from the denser to rarer. So if you increase a little bit, then the incident ray will fall down, and then it will passes through the surface of the separation. What will happen if you increase this theta to a little bit? Suppose this little bit, then what will happen? Then the incident ray will be like this and the refracted ray would be like this. So when light will go through in this way through the surface of the separation, then this angle is actually 90 degree, right? So for making this angle 90 degree, what is the angle is creating here? That is actually the theta C. That theta C is actually the critical angle. C for critical and theta is the expression of angle. So this is the same thing. You just think this is the second part of the image, of the same image. So the theta 2 and theta 1. See, and this theta C is definitely greater than theta 2. But this 90 degree is also greater than theta 1. So comparatively, when this theta C will form, this angle, the refractive angle would be 90 degree. So that is the critical angle. So simply we can say, when light incident from the denser to rarer medium, for creating 90 degree refractive angle, the angle which is created in the denser medium, that is the critical angle respective to this medium. Okay, if it is diamond and if it is water, then the critical angle would be different. If it is diamond and this is air, the critical angle would be different. But it is always think that this angle, this critical angle will form in the denser medium. not in the rarer medium. Critical angle will form always in the denser medium. Now you think this theta c actually, not theta c, is actually theta 2. So this theta 2 is this theta 2 also, but it's actually theta c. Now we can say this is theta c. If the incident angle is greater than theta c, what will happen? Then the refracted ray will just come to the previous medium and it would not be refracted, it would be a reflection of the light. Think about the picture. So theta 2, think theta 2 is 65 degree, suppose. So now if the angle is 70 degree, then what will happen? It will definitely reflect to the previous medium. So when this angle, suppose this is theta 3, okay? When this theta c is greater than theta c, the angle of incident is greater than the critical angle of that medium, then the total internal reflection will happen. So suppose this is 35 degree and this is 55 degree, okay? So no critical angle will create, but here this is 55 degree. When it is 55 degree, it became 90 degree. So when the refractive angle is 90 degree, when it is formed, then this angle of the denser medium, which was 55 degree, suppose this is the critical angle. And when light incident makes a bigger angle than the critical angle, suppose this theta c is 70 degree, then the light will never go to the other medium. It will come to the previous medium, and this is total reflection, and that is why it is known as total internal reflection. I hope you understand the process. Now the beautiful part will be happening, like what are the mathematical expression? We know here, think about it. We know that from the law of reflection that n2 sine theta 2, okay, is equal to n1 sine theta 1. n2 sine theta 2 equal to n1 sine theta 1. You know it from the law of reflection, second. So now this n2 is the refractive index of water, which is 1.3. Okay, think about it. This sine theta 2 we don't know, but this n1 is the refractive index of air, which is 1.00, and this theta 1 we know this is 90 degree. This is n1, so this is theta 1. n2, so this is theta 2. Simple. Now if you want to find that what is the critical angle, then how to find? Before going to explain, think about it. n2 sine theta 2, okay? Theta 2 is actually n1 sine theta 1. This theta is 90 degree. So in case of critical angle, this would be 90 degree, and we know the value of sine 90 degree is 1. So if it is 1, then n1 sine 90 is n1, because n1 will be multiplied by 1. So now we can see that n2 sine theta 2 is equal n1 times 1. That's because 90 degree is 1 sine 90. So what is going on? So now we can see this sine theta 2 is equal n1 by n2. And now we also can say this theta 2 is actually theta c, because as it is theta c, it was 90. So we can say this is theta c. So we can say that sine theta c is equal n1 by n2. So from that equation, if we can draw another equation, beautiful equation, this is critical angle is equal to sine inverse n1 n2. Then we also can find the critical angle using this equation. How come? You see that critical angle was formed in the second medium. Okay? So the refractive index of the second medium would be here, and the refractive index of the rarer medium would be here. So if we know the refractive index in both medium, we can find the critical angle. So now the critical angle would be sine inverse. This n1, that means this one. The refractive index of air is 1.0029, but though it is supposed to say that 1.00, and the refractive index of water is 1.33. Now we find the value of let's say that 1.0029 divided by 1.33, this is 0.75. So you can say that theta c is sine inverse 0.75. So if we say sine inverse, then we can say that shift sine 0.75 is actually 48.59, or we can say 48.6 degree. So theta c is 48.6 degree. So if light falls from the water to air, then theta c, the critical angle, should be 48.6 degree. So if the questions that if light incident in water in 50 degree, then what will happen? If this theta 3 is 50 degree, then think about it. This theta 3 is 50 degree, that means it's bigger than the critical angle. So light will be coming back to the previous medium, that means in water. So that is completely a total internal reflection. And this phenomena is happening in the optical fiber. In the optical fiber, you know that in the optical fiber, this is the core of the optical fiber, and there is a clad of the optical fiber. So both has a different refractive index. When light falls in the optical fiber, then it's always doing the total internal reflection. So it falls here, and then it comes there, and then it comes there. So if I draw a normal, this angle, which is always greater than the critical angle, and that is why through the optical fiber, light is passing through the total internal reflection. So inside this is core, and outside it's called clad. So inside the core and the clad, there are two different type of refractive index, like 1.5 and 1.7 respectively. So these things happen. I'm coming up with another video explaining the optical fiber, rainbow, prisms, binocular, periscope, like this. So I hope you understand this process. So this is about the critical angle and the total internal reflection. You need to know the definition properly. You need to know the concept. So if you know these things, the theta c is this, I hope you can solve it. I really hope you can solve it. If you know the refractive index of two different medium, you can find the value or the refractive index. So this theta c is critical angle, and when the angle is more than critical angle, it's total internal reflection. So simply I'm explaining it. So this is the primary level explanations of the critical angle and total internal reflections. In the next video, I'm coming up with the next topic, and we need to know, we have to solve some mathematical problems in this chapter. For that, we need to understand the concept clearly. So if you have any recommendations or feedback or comments, put it in the comment sections in my YouTube channel, and of course do let me know your vibrations. Do you really doing good in my videos? Is it really helping to you? So take care, stay well, see you in the next class.